Laws of sets. Last time we had already stated these laws. We said the first thing I'm going to write is the commutative law. So on the commutative law, we said, for example, addition and multiplication, those are commutative, meaning if you say 1 plus 2 is the same as 2 plus 1, minus and division, they are not commutative. If I say 2 divided by 1, it's not the same as 1 divided by 2. So union and intersection, those two are commutative. For example, if I say A intersection B, this is the same as B intersection A. So that is a commutative. And then we have got associative. Associative law or associativity law, this one is going to relate three different things. And the good, please, we should know them from here because we are going to talk about them when we come to binary operations. So when you're talking about associativity, you are talking about three things. When you say A union B union C, this is the same as A union B and then union C. So you can start with the first two and then you perform the operation with the first one, or you start with the first two and then with the last one. Even when we use intersection there, it will all be the same. That's the associative law. And then we've got the distributive law. Distributive law, just distributing. So if we have A intersection B union C, you see I've used different things here. Of course they can be the same. This is the same as, we're going to get the A intersect to distribute with B, so that is going to be A intersection B. And then we'll get the sign that is on the middle, that's the union. And then we'll get the A intersect to distribute with C, so that will be A intersect C. Okay, like that. So that's the distributive law. And then the other one you are expected to prove is the De Morgan's law. Now, De Morgan's law is just a law of distribution. When you've got A intersect B complement, this is the same as A complement, and then the sign changes to union and then B complement. We've distributed this complement to A and B. So if they say state De Morgan's law or the union of two sets, then it is A union B complement. This is going to give you A in complement intersect B complement. This is De Morgan's law or the union of two sets. This is De Morgan's law or the intersection of two sets, where you start with the intersection there. So hope that is okay. Now, how do we get to prove this? So on proving, I'm going to start with associativity, distributive, and then De Morgan's. I'm not going to prove commutative. And here we are using the general way of proving. Of course, you can prove using Venn diagrams. But if they ask you to prove and they've given you 5 marks, don't use Venn diagrams. So let's start with the associative law. A intersection B intersection C is the same as A intersection B and then intersection C. So this is what we want to prove. Or we can also use union there, even here to be union there, union. It will all be the same, so it's the same procedure. Now, one thing you need to be aware of is when you talk of AND in sets, this means intersection. If you talk of OR in sets, this means union. So these are the things we'll be using. So when you want to prove that this portion is equal to this portion, remember we talked about a subset. If I say A is a subset of B, and then at the same time B is a subset of A, it means that A is equal to B. So this is the method we are going to use to prove these sets. Like if A can go into B and B can go into A, meaning these two are the same, how can they both go into the other? So that's what we want to do. So we're going to show that the left hand side is a subset of the right hand side, and the right hand side is a subset of the left hand side. So starting with this one, we're going to show that it is a subset of the other side. So the link is in the description. Those people who are not able to join, you can inform them. So let's get this side first. I'm starting with the left hand side, and then I'm going to say let x, just any element, in this case I'm using x, be a member of this set A intersect B intersect C. So that is the proving we've started. So we just let that x is a member of A intersect B intersect C. This means that x, if x is a member of A intersect B intersect, then x is a member of A. So where there is intersect, I'm going to put and B intersect C. So this is the meaning: x is a member of A and x is a member of B intersect C. And then this also means that x is a member of A and so also this part. So actually just on top here, the way I've written it, let me say x is a member of A and x is a member of B intersect C. So I've just divided where there was intersection, I've put and, meaning x is a member of A and x is a member of B intersection C. And then from here we have got x being a member of A and x being a member of B. Again, where there is intersection, I'll put and x being a member of C. So we can see that x is a member of A and x is a member of B and x is a member of C. So since we started with this part, we want to go to this part. Our aim is to put A and B together. So I'm going to put A and B together. So I'm going to say x is a member of A. The and which is here, I'm going to put intersect B. And then we'll get this and x is a member of C. And then we can therefore say x is a member of, we'll get this A intersect B, and then this and we are going to put intersection, we'll get now the C. So what we've just found is that this has given us this, meaning that the part we started with, this means the part we started with, the A intersection B intersection C, is a subset of the part that you found, that is A intersection B intersection C. So we've just shown that this part is a subset of this part. After finishing that one, we also show that this part is a subset of this one. So that is the next thing that we are going to do. So after writing this, you don't rub, and then you're just going to say conversely. Conversely just means, you can just speak out. I cannot see, I'm not paying attention to. Yes, please go on. Okay, so you just let any letter like be an element of that set. So you are just getting any element to be in this set. Yeah. So what you've done, now we are saying conversely or in the same way, let. So that's why we are saying let. So let x be a member. Now in this case it will be a member of this part. A intersection B intersection C. Your hand is still up. Is you still have a question? Okay. Yes. Where? All right. So we are saying in the same way or conversely let X be a member of A intersection B intersection C. So we've now gotten this part. And then we are going to say this means that X is a member of A intersection B. I've written this part, and then this intersection which is A, we are going to put and X is a member of C. So intersection means and then again this will mean that X is a member of A. This intersection which is here, we are going to put and X is a member of B, and then we have got another and X is a member of C. So now we are moving from this one, we want to go to this one. So I'm going to pair the last two together. So that will give us X being a member of A, and so I've written this and X being a member of B. So instead of writing and this and, I'm going to put intersection the C here. After writing this, and then we'll say X is a member of A. This and here becomes intersection. It will be intersection this part. B intersection C. So what we've just done, this shows, so these are statements to write. This shows that the part that we started with, A intersection B intersection C, is a subset of the part that you found A intersection B intersection C. Remember, in the first instance we found that this was a subset of this, and then we found that this is a subset of this, and then now we can make the general conclusion. Since A intersection B intersection C is a subset of A intersection B intersection C, and the other part which is the A intersection B intersection C is also a subset of A intersection B intersection C, then A intersection B intersection C is equal to A intersection B intersection C. So there, that is how you get to prove the associative law. Are there still questions? Yes, Temba. Okay, okay. Yeah, you are going to understand on the next one if you are really left out behind on that. Just try to follow, and at the moment where you are confused, make sure you ask before we go even much further. Oh, sorry for that. Okay, let's look at the distributive law. When you've got A intersection B you, uh, intersection C, let's use union here. We say we can distribute the A intersection, so that will be A intersection B and then union A intersection C. So this is the distributive law. So starting with the left hand side, we'll say let X be a member of the first part, A intersection B union C. So this means that then X is a member of what? A, but where there is this and intersection, I'm going to put and. X is a member of this other part, which is the B union C. So from here, and then we'll say X is a member of A and X is a member of B. This union which is here, we are going to put O. X is a member of C. Anyone left out behind on this? Alright, so from here, now, if I say you should buy, I want you to interpret what that means. You should buy a pen, let me say a book, and a pen or a pencil. What do I mean? If I say you should buy a book and a pen or a pencil, so which one is a must you should buy? You should buy a book and a pen or a pencil. Which one is a must? Like, which one shouldn't you miss? That's it. So that means that I can come with a book and a pencil, or I can come with a book and a pen. So this is the same thing here. X is a member of A and X is a member of B, or X is a member of C. Meaning that X is a member of A and X is a member of B, or X is a member of A and X is a member of C. I don't know if you've gotten the sense. So X is a member of A, and just on this stage, X is a member of A and X is a member of B, or X is a member of C. It means I can have X being a member of A and D, a member of B, or I can have X being a member of A and a member of C. A is a must, but you can either come with B or with C. So that's the meaning. And then from here, we'll say X is a member of, this means it is A where there is and, we'll put intersection B, and then we have got O. X is a member of A where there is and again there, we'll put intersection C. This means X is a member of A intersection B where there is O, we'll put union, and then A intersection C. So what we've just shown here is what we started with. This means what we started with, X, I mean just the A intersection B union C is a subset of what we have found, that is the A intersection B union A intersection C. Any question here? Okay. Now we've shown that the left hand side is a subset of the right hand side, and then we need to do the same thing. Conversely, or in the same way, let X be a member of now of the right hand side. A intersection B union A intersection C. That means that X is a member of A intersection B where there is union. I'm going to put, or X is a member of A intersection C. This means that X is a member of A and X is a member of B, or X is a member of A and X is a member of C. So more on this stage, we are just changing like we did on the previous one. We have got X is a member of A and X is a member of B, or X is a member of A and X is a member of C. That means X is a member of A and X is a member of B, or X is a member of C. We can simply write it like that. Anyone left behind? Just the same way we did on the previous one. Now we're just going back. If you come with a book and a pencil, or a book and a pen, we can just say buy a book and a pencil or pen, direct like that. So this means X is a member of A where there is a, and X is a member of B where there is O, or put union C. This means that X is a member of A, where there is and, put intersect, and then you've got B union C. So what you've just shown is that this shows what we started with, the A intersect B union A intersect C is a subset of A intersect B union C. Now that we've shown that the left hand side is a subset of the right hand side and vice versa, then you can now make a generic statement or a general statement. Since left hand side is a subset of the right hand side and right hand side is a subset of the left hand side, then right hand side is equal to left hand side. Now where I've put left hand side and right hand side, you can be putting those. This is a left hand side, this is the right hand side, so you can put those. Is there a question, Temba? You're still very behind. Anyone else who's behind? Maybe the tricky part which will be there is the De Morgan's law, the one we are going to. So, De Morgan's law. This is the only law that differentiates a person at university with a secondary school student, because it's just something that sounds new. Okay, De Morgan's law, I'm going to use the law of intersections. A intersection B complement is equal to A complement union B complement. So start with the left hand side. Let X be a member of A intersection B complement, like that. So if X is a member of A intersection B complement, meaning that X is not a member of A intersection B. Does that make sense? If X is a member of A intersection B complement, meaning X is not a member of A intersection B. And then from here, this will mean that X is not a member of A, and then the and here, the intersection, of course we know intersection means and, but this one becomes tricky because we are not using member, we are saying not member. Instead of and, we'll put O, X is not a member of B. Why? We are not using member of, it's not a member. So this is where I'm saying the De Morgan's law will become a bit tricky. So X is not a member of A, meaning that X is a member of what? A complement. Or X is not a member of B, meaning that X is a member of what? B complement. This means that X, sorry, I've put not a member here, it's supposed to be member since it wasn't a member of. So X is a member of A complement, or X is a member of B complement. This means that X is a member of A complement union B complement. So this shows the left hand side we started with, the A intersection B complement is a subset of A complement union B complement. Any question here? So you see, X wasn't a member of A. it means it's going to be a member of, like, if something is not within, then it is outside. Something is inside, then it is not outside. If something is not outside, then it is inside. So that is the principle we are using. If X is not a member of A, then it will be a member of what is outside A. Put the charger. All right. Now we'll say conversely, in the same way, let X be a member. Now we'll get the right hand side, A complement union B complement. So this means that X, in this case, it's just more like what we've done on this part. We are just going in the opposite direction. So if X is a member of A complement union B complement, meaning that X is not a member of A. Now we are supposed to say O, but look, this is what? This is not a member, and X is not a member of B. So I would have first started by saying X is a member of A complement and X is a member of B complement. I'm supposed to use O here because of the union, but as we get to change X, since we are saying is a member of A complement, then X is going to be not a member of A. Now this is not a member. The thing has changed because we are talking about member, but now it's not a member. Instead of it being the and we are now using O. And then X is not a member of B. So this tells us that X, I've again changed something here. The O is supposed to first, if we have people who are following, this is union, we're supposed to use O at the start. X is a member of A complement, or X is a member of B complement. And then as we now change to not a member, that's when it becomes and X is not a member of B, meaning that X is not a member of A where there is and there intersection B. Well, this is not a member. So if we change into being a member, then we are going to put a complement. So this shows what we started with. A complement union B complement is a member of A intersection B complement. After finishing this, we've shown that the left hand side is a subset of the right hand side, and the right hand side is a subset of the left hand side. Then conclude. Since left hand side is a subset of the right hand side, you can put what the left hand side is. So everything that we've done here, show it when writing the answer. Otherwise you'll do something. Ones are always, they feel bad giving you 4 marks. Their aim is to make sure that they mark you wrong. That's their aim. So there we've shown, since the left hand side is a subset of the right hand side and the right hand side is a subset of the left hand side, then the right hand side is equal to the left hand side. So this is how you prove these laws. That's how you get to prove them. You can also prove using Venn diagrams. Let's prove this. A union B complement is equal to A complement intersection B complement. Okay, so we have got I know we know what A union B means. A union B means everything in A and in B, but we want the what a complement, meaning what is outside that. So what we are going to shed is what is outside here. Okay, like that. And then let's shade this one. A complement is what is outside A. So I'm going to put it in blue. And then we'll shade now B complement. I'm going to put it in red. What is outside B? Oh, oh. So there. Now we want where the blue lines are meeting with the red lines. So if you see in this region, the blue lines are not meeting with the red lines. In this region also, they are not meeting. So those two regions will not be included. This portion will not be included. And also this region will not also be included. So this is basically the same. You can see this region was also included. So we've also shown that they are the same using a Venn diagram. So you can also prove that.